Hello everyone, let me present you the work on the topic the investigation of the dependence of the registered patterns of scattering light on changes in the optical power of probing radiation in digital diaphanoscopy. Today, around 60% of people in the world suffer from diseases of the pronasal sinuses, and the method of digital diaphanoscopy can provide fast, safe, and painless diagnosis of such pathologies. The aim of my project is to determine the range of changes in the power consumption of the LED applicator and the optical power emitted by the applicator sufficient for visualization of the maxillary sinuses with various anatomical and gender features. The digital diaphanoscopy method consists in translucent maxillary sinuses by anatomically shaped LED applicator with two sources of radiation, visualizing the scattering pattern of light by CCD camera and the following digital processing of the obtained images by specialized software. We identified a great influence of anatomical and gender features on the result of diagnosis, so we carried out a simulation of the magnitude of decrease in the signal which passes through environment. We established 4 different hypodermis thickness for female and for female, and also performed simulation with cystic and tumor tissues inside of maxillary sinuses for 2 sources of radiation. As you can see, there is a difference in decrease of radiation power in female and in male, while this decrease has more pronounced character in the infrared range. We can see that absorption of light in male is higher than in female. Based on the simulation results, the experimental setup was upgraded. So, the controller of LED applicator brightness is designed in addition to the previously developed prototype to control the output power of the probing radiation. Additional software allows to change the voltage supplied to the LEDs as well as measure the current flow in real time and calculate the power consumption. So we can select the desired range of radiation power for specific volunteers and patients in accordance with anatomical features and gender. To determine the power range sufficient for visualization of pathology in male and in female, 20 patients were studied with a change in the optical power of radiation from 0 to 750 mW in 50 mW increments. The camera exposure time did not change. The analysis of the obtained results showed that in healthy female volunteers, the maxillary sinuses were visualized in the range of the optical power of LEDs equal to 300 to 1500 mW. In examination of male, we can see that the maxillary sinuses were visualized in the range of 650 to 750 mW. Currently, additional experimental studies are being conducted to form a database and identify diagnostic creations for various pathological changes, taking into account the identified ranges of the optical power of probing radiation that have the greatest sensitivity to visualization of pathological changes in the maxillary sinuses in different study groups divided by gender. Thank you for your attention.